Exercise 45. So here we have the well-known units of Fahrenheit and Celsius for measuring temperatures, and these two units are related by an equation of this particular equation, which you can see is a linear equation in C and F. C is the Celsius temperature and F is the Fahrenheit temperature for the same object. Now we have been asked to draw the graph of this equation in the FC plane as well as the graph of the equation C equal to F, and we have to decide whether these two graphs intersect at some point, so that at that point the Celsius and Fahrenheit temperatures of the object will be the same numerically. So here are the graphs, and you can see, okay, in drawing these graphs, obviously 2 points are sufficient because the graph is going to be a straight line. This is a linear equation in F and C. So first what we did, we put F equal to 32 so that C becomes 0. So that is this point, 32 comma 0, that is 1 point on this graph. And the other point is this convenient one. If you put F equal to 50, C turns out to be equal to 10. So this is the other point. So joining them, we got the straight line, which is the graph of this equation, and at the same time we have drawn this line also, F equal to C. It turns out that they intersect at this point, minus 40 comma minus 40. So that is the value at which the Celsius and Fahrenheit temperatures are the same for an object. Minus 40 degree Celsius is the same as minus 40 degree Fahrenheit, which you can verify by putting minus 40 here also in the equation. If you put F equal to minus 40, you will see that C also comes out to be minus 40. So next, minus 40 degree actually. (46) The Mount Washington Cog Railway. Okay, you have to write some things. The exercise is a bit long. It says about how civil engineers calculate the slope of road beds and other similar surfaces which may not necessarily be horizontal. Okay, so the exercise is like this. Civil engineers calculate the slope of road bed as the ratio of the distance it rises or falls to the distance it runs horizontally. Same thing, slope is after all slope. runs horizontally. They call this ratio the grade of the road bed. The grade of the road bed. Okay, usually written as a percentage. Along the coast, okay, so these are some examples. Commercial railroad grades. Railroad grades are usually less than 2%. Okay, so not much. In the mountains, they may go as high as 4%. Okay. As high as 4%. Highway grades are usually less than 5%. So on highways, it's allowed for the road to be somewhat steep, steeper than a railway track. Understandably, because cars can be controlled even if you are in a steep part of a road, but it's much more difficult to control a train if it's too steep. Okay, then what is the exercise? The steepest part of the Mount Washington Cobb Railway in New Hampshire has an exceptional 37.1% grade. Wow, that's quite high. I mean, compared to these things, the steepest part of the Mount Washington Cobb Railway in New Hampshire has an exceptional 37.1% grade. Along this part of the track, The seats in the front of the car are 14 feet above those in the rear. Damn, man. The seats in the front part of the car are 14 feet above those in the rear. About how far apart are the front and rear rows of seats? Okay, so slope is still rise or fall divided by run. So how far apart the rows of the seats? That means the front part is 14 feet above the rear part and the grade is 37.1%. So since it's expressed as a percentage, so we have to divide it by 100 to find the slope. So that is the slope. So that means the approximate distance between the front and the rear rows of seats is, you have to divide this 14 by the slope, which is 0. If you divide this one by 100, you get 0.371, and approximately this is 37.74 feet. The unit is feet. Yes, because it's 14 feet. Let me just see whether what we have calculated here is correct or not. So the slope is rise divided by run. Slope is rise divided by run. So that means run is rise divided by slope. Yes. So this is the answer. Next, we come to again some more exercises under the heading theory and examples. 47 by calculating the length of its sides. The lengths of its sides show that the triangle with vertices at the points A1, 2, so coordinates are given. A1, 2, then B5, 5, and C4, -2. is isosceles but not equilateral. So it's quite straightforward. We just have to find the lengths of the three sides. Which we calculate one by one. I think it will be better to write like this. So length of the side AB so this gives us how much? 4 square is 16, 3 square is 9, so that means 25, so this is 5. Then length of the side BC is 5 minus 4 whole square plus 5 minus 2 means 5 plus 2. So this is square root of 50, which, okay, it's not 5. That's what I mean, that we can see from here. And then length of the side AC (1 minus 4 whole square plus 2 minus 2 means plus 2. So this is minus 3 whole square 9 and 4 square 16. 9 plus 16 is 25. So this is again 5. So we can see that AB is equal to AC, but they are both different from this length BC. Hence, and none of them is equal to BC. Is isosceles but not equilateral. then 48. Show another similar one. Show that the triangle with vertices a 0, 0, b 1, root 3, and c2, 0 is equilateral. So this time it will be equilateral, unlike the previous one. Again, the procedure is same. We have to calculate the length of the three sides. So AB, A is the origin, so it's very easy. Three plus 1 is 4, so that means this is 2. BC, 1 minus 2 square plus root 3 minus 0 square. 1 minus 2 is minus 1, its square is 1, and plus 3 is 4, so this is again 2. And CA or SC is 2 square plus 0 square, because A is the origin. So this is again 2. Hence, this is equilateral. Then 49. Show that the points A 2, minus 1, B 1, 3, and C minus 3, 2 are the vertices of a square. And find the fourth vertex. That is coordinates of the fourth vertex. We have to first of all show that these three actually are the vertices of some square, and we have to find the fourth vertex of that square. Just give me a moment. if one wants, one can plot these points in the xy plane, and that way also one can try to show that show the thing or solve the exercise. But since it comes under theory and examples, so it's better to solve using theoretical means. Although that plotting method will almost immediately show you that yes, they are the vertices of some square, and you can guess the fourth vertex. But let's just do it theoretically. Note that if we calculate the length of the side AB, say this one, then it becomes 2 minus 1 whole square plus minus 1 minus 3 whole square. Okay, so this is 1, this is minus 4, so 16 plus 1 is 17, and the other one is BC. If we calculate that length, then we get 1 minus minus 3 is plus 3 whole square plus 3 minus 2, again 16 plus 1 is 17. That means wherever these points are, AB and BC have the same length. These two line segments have the same length. Okay, so that is one thing. Now the equation of the straight line passing through A and B is, okay, so we are given 2 points, so we can write the point slope form of the equation, provided we know the slope. Let's calculate the slope quickly. So it is minus 1 minus 3 divided by 2 minus 1. That means the slope is minus 4, and since the line is passing through, you can use any one of these 2 points. We have already seen these things before, so let us use this one. Y minus 3 is equal to minus 4 times x minus 1, or 4x plus y is equal to, so this is minus 3, so it will become plus 3 plus 4. 4x plus y is equal to 7. So this is one thing. So this is the equation of the straight line passing through A and B. Just like that, the equation of the straight line passing through B and C. For this one also we need the slope. So the slope is 3 minus 2 divided by minus 1 minus 3. Okay. So the slope is 1 over minus 4. That means minus 1 by 4. So that means the equation will be, if we use still this point, then y minus 3 is equal to minus 1 over 4 times x minus 1, or it will be what? We have x on this side, okay, but with a minus sign. It will be x plus 4y. Will it be x plus 4y or x minus 4y? Have we made a mistake somewhere? Equation of the line passing through B and C. 3, oh yes, see, 3 minus 2 divided by 1 minus minus 3. So that means 4. It's not minus 1 over 4, it's 1 over 4 actually. Or, so okay, this means 4y, or let's just take 4y on that side. So on this side, on the right hand side, we have x minus 1. X minus 1 is equal to 4y minus 12. Okay, so that means x minus 4y plus 12 minus 1, that means plus 11, equal to 0. These two slopes also tell us something else. It tells us that the lines AB and BC, the line segments AB and BC are actually perpendicular to each other. That is because if you multiply the slopes minus 4 and 1 over 4, you get minus 1. So the lines should be perpendicular. So wherever these points A, B, C are, I mean we know where they are, they will look like this: A, B, C. Okay, the lines are perpendicular to each other. Okay, so that it will be nice to actually draw this. Draw means at least see how the points are with respect to one another. Somewhat like this: A, B, C. Okay, so that means we have to find that point which will complete this square. We have got the equation of this line BC, which is x minus 4y plus 11 equal to 0, this one, and the equation of this line also, 4x plus y equal to 7. So what shall we now do? That is the question. If you extend this, I mean the way I have drawn this, it's not very nice, but you can understand. You will have the required point here. To find the coordinates of that point, we need to solve these two equations. We need to find the point of intersection of these two lines. So that means first of all we need the equations of these lines. Now we can find the equation of this line by considering this, because this line C, which is passing through C, it has to be parallel to the line AB. So we write accordingly. The equation of any straight line parallel to the line passing through A and B is 4x plus y equal to C, where C is some real number. We already know this. Parallel lines differ only in the constant term in their equations. The other part, which involves the variables, those parts are actually the same. Now if this line is to pass through the point C, then the coordinates of C must satisfy this equation. What are the coordinates of C? I wrapped that on. -3, 2, then 4 times -3 plus 2 is equal to C, or C is equal to -12 plus 2, that means -10. So this line is, actually we should write it has the equation, but you can understand the line itself is given by that equation. So we simply write, so this line is 4x plus y equal to -10. Similarly, we can find the equation of this line also, which is parallel to the line passing through B and C and is itself passing through A. The equation of any line, line means straight line, parallel to the line passing through B and C is x minus 4y equal to C prime, where C prime is some real number. Okay. If this line passes through A, the coordinates of A are 2, -1. Then C prime equal to 2 minus 4 times -1 is 6. So this line is x minus 4y equal to 6. Now we have to find the point of intersection of this line and this line. You just have to solve these two equations. Note that -2, -2 lies on both the lines this and x minus 4y equal to 6. Is it really true? Let us see. If we put x equal to -2, we get -8. -2 is -10, yes. -2 plus 8, because y is also -2, is 6, yes. So these are the coordinates of that other point, which if we call it D, then these are the coordinates of D. So the fourth vertex of the square is this point. Oh, by the way, we forgot to conclude that this actually is going to be a square. That is, A, B and C are actually 3 vertices of a square. We should have concluded that here itself before writing these things. And how are we able to conclude that? You see, we have shown that these two line segments have the same length. That is one thing. And the other thing is that the slopes of these two lines give us are such that their product is -1. So that means these two lines are perpendicular to each other. So these two pieces of information tell us that these 3 points, these 3 A, B and C must be the 3 vertices of a square, like this. So then after that we are doing all these calculations to find the coordinates of the fourth vertex. That we should have written here itself, but I just simply mentioned it that the slopes of these two lines show that they are perpendicular to each other. We should write that. Okay, so you just do that and make the solution complete. So I am ending it here. Then exercise 50. The rectangle shown here, there is a figure. Has sides parallel to the axis. it is 3 times as long as it is wide. And its perimeter that is also given is 56 units. Find the coordinates of the vertices A, B and C. Excuse me. We don't have space here, we have to draw there. The figure is like this. There are axes, of course. This is the x-axis. This is the y-axis. Okay, so this is the rectangle and its vertices are A, B, C and D, where it is given that the coordinates of D are 9, 2. Okay, it is 3 times as long as it is wide. That means this length is 3 times this length. BC is 3 times AB. And the perimeter is also given to be 56 units. So we start the solution like this. Let the width of the rectangle be x units. That means AB and CD are x units. Since the rectangle is 3 times as long as it is wide, we have AB equal to CD equal to x units and AD equal to BC equal to 3x units. Now it's given that the perimeter is 56. Hence 56 equal to AB plus BC plus CD plus DA. So it will be x plus x, not in this order of course. I mean you will have 2x's and 3x's. So that means 6 plus 2, 8, which implies x is equal to 7. Okay, so this is 7 and it's 3 times the width, so this is 21, and that means the coordinates of these vertices will be 21. So this much is 9. Now if this much is 12, then it will be 21. 9 plus 12 is 21. So that means 12 means on the negative side of the y-axis. And if this is, at the same time this is 7, so if this much is 9, then additionally we should have what here? Wait, is it making sense? Okay, I'm a little confused here. If how can this be 7? If x is 7, that means what? But besides that, I see one more problem. The x-axis also has, let's just change this, let's call it z units. Z is 7. Oh, okay, what the hell? I'm confusing this 9 with this height. 9 is the horizontal length, 2 is the height. So that means since this is 7, this much is 5. Okay, now it makes sense. I mistook it for something else. Hence, the coordinates of the points A, B and C okay, so minus 12 plus 2. Then minus 12 minus 5, because then 5 and 2 will give us 7. And what about this 9 minus 5? Respectively. This is minus 12 minus 5 and this is 9 minus 5. This B and C should have the same y coordinate, Yes, A and B should have the same x coordinate and like that. Then exercise 51. Three different parallelograms have vertices. Three different parallelograms have vertices at these points -1, 1, 2, 0 and 2, 3. Sketch them and find the coordinates of the fourth vertex of each. Okay, so this time we have to sketch, and from the figure itself we have to find the coordinates of the fourth vertex of each one. Can we draw the figure here, or will it be better to draw it there? I think it's better to draw the figure here. -1, 1, 2, 0 and 2, 3. Let's first put the points on the axis. Okay, -1, 1. So this is 1 point, 1 vertex. 2, 0. So that means this one, and 2, 3. 1, 2, 3. If we join these points, we get a triangle. Okay, so this is -1, 1, 2, 0 and 2, 3. Now its it is said that these are vertices of three different parallelograms. So if you extend these lines, well, not extend these lines, but if you draw, I mean, you can understand that you can have one parallelogram like this, you can have another parallelogram like this. So that way you try to think of the three vertices. You can have another parallelogram like this. So if you draw all the things, ultimately you will get a thing like this. Minus 1. Let me first draw and then we will see. 4. Then I have it drawn for us here. Five, 2. Like this. Let us now write the coordinates of these points. First, the ones that are given: 2, 0, 2, 3, and -1, 1. So these three vertices are simultaneously the vertices of this parallelogram, also this parallelogram, as well as this parallelogram, three different parallelograms. And the other vertices are these, which if one draws the figure carefully, after drawing these lines, they will find the coordinates of these other vertices to be these: -1, -2. Okay, so these are the unknown vertices and their coordinates. So this is the solution. And we can write here itself. Exercise, the next one, exercise 52. A 90-degree rotation counterclockwise about the origin takes 2, 0 to the points 0, 2 and 0, 3 to the point -3, 0, which is easy to see. where does it take each of the following points? And the points are these: A 4, 1, B -2, 3, C 2, -5, then D x, 0, where x of course is any real number, E 0, y is also any real number, F, this is the most general one, x, y, and there is a part G also. What point is taken to 10, 3? So under this rotation, where from 10, 3 is coming? That we have to find. What point is taken to 10, 3? So we will find the most general one, and that will answer all the parts. We solve part F. This will automatically answer the other parts. Oh, but there was one figure also which I forgot to draw. Shall I draw it here? The figure actually is just simply it's showing some points and how they are suffering that rotation and where they are ending up. Two, 0, we can put our numbers at regular intervals. So this is 2, 0, this is taken to 0, 2. You can clearly see it here. 90-degree rotation in the counterclockwise direction takes this point to this point. Then 0, 3 is taken to -3, 0. and then minus 2 comma minus 3, that point is also taken somewhere. We don't yet know where, we have to find out. Like that we have 4 comma 1. That point is also taken to some, so these are the points we have to find their final position after that rotation. And they have shown many points, 2 comma minus 5 or 5. Okay, so we are saying that we are going to solve f. So now x and y, each one of them can take any real value. So we have to look at all the possible cases. Of course, there are infinitely many. We can't expect to look at each one of them separately, but we will see some 1 or 2 cases. When or instead of writing like when, let's directly write this. The point zero comma 0 remains fixed under this rotation, because even after rotation, that is the only point in the plane that stays fixed. It does not change its position. So that is one case when x comma y equal to 0 comma 0. Okay, for x not equal to 0, the point x comma 0 is taken to 0 comma x. We have already seen this when x is positive. For example, 2 comma 0 is taken to 0 comma 2, which you can clearly see why that is the case, because a 90-degree rotation will take all the points on the positive side of the x-axis to the positive side of the y-axis, and in such a way that for each one of them its distance from the origin does not change, that remains fixed. However, if the point is on the negative side of the x-axis, for example this point itself, minus 3 comma 0, then it comes to the negative y-axis, again at the same distance from the origin. So there also it changes to 0 comma minus x. For example, if x is minus 3, then this point is taken to the point whose coordinates are 0 comma minus 3. So in both the cases x comma 0 is taken to 0 comma x. If x is positive, then there. If x is negative, then there, below the x-axis. Just like that, for y not equal to 0, the point 0 comma y, this is now a point on the y-axis that is not the origin. Either it is above the origin or it is below the origin. If it is above the origin like 0 comma 3, then that is changed to the point minus 3 comma 0. So the point is taken to minus y comma 0. But if the point lies below the x-axis, for example 0 comma minus 2, is that also taken to minus of minus 2 comma 0, that is 2 comma 0? Yes, because the rotation is still counterclockwise and by an angle 90 degree, through an angle 90 degree. So the point will come here, but its distance from the origin will stay the same. So it will become, if it is say minus 2 comma 0, then it will become 2 comma 0. For example, this one, this point is taken to 2 comma 0. So this covers all the cases where the point lies on the y-axis except at the origin. Okay, so we have seen what happens to this point, what happens to the points on the x-axis, other points on the x-axis, and what happens to the other points on the y-axis. Now we can go outside of the axis in the plane. Now assume that x and y are both non-zero. The equation of the line, say our xy is say here, x comma y. Now what is the equation of this line? The equation of the line passing through x comma y and the origin. I have intentionally taken the point in the fourth quadrant so that we can see what is happening in this case. Of course, this is general, so this x comma y can lie anywhere in the plane except on the axis. So it can as well lie in the first quadrant or second or third. But let's just see the fourth one as a change, because usually when we draw such things, we almost always consider the first quadrant. Is, now we cannot use, since our x and y, these letters have been used to denote this point, which although is arbitrary but fixed in the plane, we have to use other variables, okay, other names for the y variable and x variable. So let us denote the y variable by v and the x variable by u, say. Then since this line is passing through the origin, it has the form y equal to mx, where m is the slope. The slope of this line is y divided by x times u. Now when we perform that counterclockwise rotation through 90 degree, the point will rotate like this, okay, and its final position will be on this line, that is perpendicular to this line and is also passing through the origin. Okay, so this point will come here somewhere exactly where, that we will decide, but we know that wherever this point will end up, that is on this line, which is perpendicular to this line. So next natural step is to write the equation of the line that is perpendicular to this line. And which is also passing through is, you take the negative reciprocal of this slope, of the slope of this line, which is y divided by x. So that means it will be minus x divided by y u. Now any point on this perpendicular line is u comma minus x by y times u, because that is the y or the v coordinate. This is the u coordinate, which is the first coordinate, and this is the based on the first coordinate, this is the second coordinate, which is the v coordinate, where u is a real number. Now we impose the second condition. You see, because we are rotating and our center of rotation is the origin, so although all the points in the plane except the origin are changing positions, the thing that is remaining constant is their distances from the origin, because each one of them is, the distance from the origin is not changing, it is rotating along that circle on which it lies, okay, whose center is at the origin and whose radius is the distance of the point from the origin. So to find the actual location of this point after the rotation, we have to impose the condition that this distance is equal to this distance. Since the rotation does not change the distance of a point from the origin, we have, what is this distance? Okay, let me just write the coordinates here, u comma minus x divided by y u. We can calculate the distance now. Square root of u square plus u square, this distance should be equal to this distance. Okay, so we have got an equation that is going to tell us something about this u. Let's keep the figure. Okay, this implies what? Since the point x comma y is not at the origin, so this is a positive real number. Let's just write, in fact, this is going to be u square y square. You see, after squaring, after taking LCM and all those things, we will have u square divided by y square times x square plus y square inside the radical sign. Now, since we don't know about the signs of u and y, if we remove square root, because there is square, we have to write not just u but absolute value of u. Or in fact, let's just write one more step. U square divided by y square times this or this or mod u equal to mod y, keeping in mind that these are this is a positive real number, so we can cancel it from both sides. Okay, hence u is equal to either y or u is equal to minus y. Now, which one should we choose? When u is equal to y, then we get then our point is y comma minus x, and when u is equal to minus y, our point is minus y comma x. So how did we actually make the choice? Have I written any hint about that here, or have I just simply left it like this? So accordingly, we have 2 points, no? X comma from x comma y we are coming. One point is y comma minus x, and the other point is y comma x. No, sorry, minus y comma x. So how to rule out one of them? From our example, for example, this one, 2 comma 0, but we cannot take that because that is lying on the axis. X comma y, u is equal to y or u is equal to minus y. In both the cases, the points are lying on that line, on the perpendicular line, and the distance is the same from the origin as this distance. So that means this is the other point here. I can't seem to remember what I did here to rule out one of them. X comma y minus y comma x. It seems like u should be equal to minus y, and u equal to y gives us a sort of contradiction. Oh, okay. We have used the hypothesis that the rotation is through an angle 90 degrees, but we have not used that part of the hypothesis which says that the rotation is counterclockwise, because whether it is clockwise or counterclockwise, that will decide exactly which point we will get. Okay, so that means for that also we should do something. So my guess is this: the point x comma y will be taken to minus y comma x. Let's verify this guess with one point. Say, since we have taken our point in the fourth quadrant, so let us take the point say 1 comma minus 2. So you can just simply, without thinking of anything much, you can see that this point should have, after the rotation, the new position of the point should have positive x coordinate and also positive y coordinate. Okay, so if our point is 1 comma minus 2, and if this is what we are believing, then it will be minus of minus 2 and x. Yes, 2 comma minus 1. So this should be the point, but of course just simply saying this should be the point is not the answer. We have to rule out the other possibility that y is equal to x. I can't seem to be able to figure out that at this moment. So what I will do, I will leave the exercise here itself. After this we have another exercise, and then this set of exercises will be over. So we will continue with answering this one in the next part. Okay, so we are going to end the things here. In the meantime, you can of course think of it and come up with something so that we can rule this one out. U will not be equal to y. Somehow it will come from the fact that the rotation is counterclockwise, not clockwise. Okay, so with this we are going to put the things to an end here. So until the next video, this is me, Lucifer, from a mathematical room. Have a nice night.